Hello and welcome back. Today we are going to be looking at word problems. Many arithmetic and algebra problems will be written into paragraph form, presenting an example from the real world. So the hard part typically is not going to be the math itself, but can we translate from English to math? So let's take a look at a few key words and phrases that will need to be translated in word problems. For example, when we read the words and, more than, the sum of, plus, we are translating this English into addition. Less than, the difference between, take away from, will be subtraction as an operation. Of, the product of, as much as, brings us to multiplication for our arithmetic. Goes into, divided by, the quotient will be division. Is, are, was, were. The result will be, has, have, earns, equals, is the same as. These are all ways to set up an equation. This is equal sign. What number, a certain number? We do not know that variable. This is algebra. This will be an unknown variable, such as x, y, or z, for example. Half of a number, 1/2 times x. Twice as much as, twice as old as, 2x. Percent is out of 100. Percent means out of 100. Something divided by 100. How many times greater will mean to divide the two numbers. Now, let's take a look at proportions within word problems. Proportions show relationships between two sets of information. Let's say, for example, you wanted to make cookies. Our recipe for a dozen cookies calls for 4 cups of flour. 4 cups of flour. Here we are going to double the recipe. If 1 dozen cookies can be made from 4 cups of flour, how many cups of flour does it take to make 2 dozen cookies? Here we will double the recipe. Notice we are cross-multiplying here. We have 4 cups of flour for every 1 dozen. We compare it to 8 cups of flour for 2 dozen. If we are solving for how many cups of flour would 2 dozen cookies make, this would be our unknown. And now we can simply multiply 4 times 2 is 8. Here we are looking at cross multiplication in our proportion problems. Whenever a question gives you one set of data and part of another set, it will ask you for the missing part of that second set of data. Here we are looking at cross multiplication and proportions. To find the missing information, we will need to set up the information in fractions, just like this example. We want to be careful to put the same information in the same place. For example, we will need to put flour on top for our proportions and cookies on the bottom of our fractions here for the proportional relationship. Once we have our fraction set up, we can see what the relationship is between the two elements. Whatever that relationship is, that will be the same relationship between the other two things. So let's go ahead and try that out with a few problems. Let's take a look at number 1 here first. There are 32 ounces in 1 quart. 128 ounces equals how many quarts? Question 1. How many ounces are there in 7 quarts? Question 2. Let's set up our proportion here. We have ounces over quarts. Ounces over quarts, we have 32 ounces per 1 quart. Now we can cross multiply. 32 ounces per 1 quart will equal 128 ounces over an unknown. This is what we are solving for. Let's cross multiply. 32 times x will give us 32x. Equals 128. Now we can divide both sides by 32. $128 divided by 32 is 4. Our first answer will be x equals 4. 4 quarts. Now let's answer our second part. How many ounces are there in 7 quarts? Here we go back to ounces over quarts. 32 over 1. $32 over 1 equals x over 7. X over 7. We need to know how many ounces. That is our unknown. Let's bring this down so we can easily compare. (32 ounces over 1 quart equals x over 7. Now we can use cross multiplication. 32 times 7 . (32 times 7 is 224. There are 224 ounces in 7 quarts. The answer for the second part of the question is 224. 4 quarts, 224 ounces. Great, now let's try number 2. A car travels at a rate of 50 miles per hour. How long will it take to travel 300 miles? Let's set up a proportion. Here we will set up miles over hours. Here we have 50 miles to the hour. We need to know how long it will take to travel 300 miles. Let's place our miles with our miles. How long would be hours? That is our unknown. 300 over x. Now we can cross multiply. 50 times x is 50x. 50x equals 300 times 1. 300. Let's divide both sides by 50 to get x by itself. This will cross out, cancel our 50 on the left side of the equation. And now we can divide 300 by 50 on the right side. Let's get rid of 1 0. So we're working with easier numbers here. 30 divided by 5. 30 divided by 5 is 6. The answer to our question is 6 hours. It will take 6 hours to travel 300 miles. And this is how we can solve proportional relationship problems within the context of word problems, where we are translating from English to math, as we are given real-world situation, paragraph form, math types of problems. Great job today. I will place the practice problems in the discussion area, and we'll see each other next time. Take care.